Welcome to Ask and Learn.
A 4.5 volt battery is connected to a bulb whose resistance is 1.6 ohms. How many electrons leave the battery per minute? Okay, so we're going to start from the relationship between voltage or potential difference, current and resistance. So we have voltage is equal to current times resistance, so V equals IR. It's pretty standard equation. We're also going to use the equation that current is equal to coulombs per second, and one electron, so is equal to 1.6 times 10 to the minus 19 coulombs, so C. And so we are going to substitute in all of these. So we're going to call this equation 1, equation 2, and this little one here is equation 3. We're going to substitute equation 2 and equation 3 into equation 1. And that's going to give us that voltage is equal to 1.6 times 10 to the 19 minus 19. So 1.6 times 10 to the minus 19. Multiplied by resistance, and multiplied by number of electrons times electrons, so number of electrons, and the unit is electrons per second, so n is just number of electrons here. So that's from substituting 3 into 2 and then 2 into 1, if that makes sense, hopefully. And then subsequently, what we can say by rearranging to make number of electrons per second, well, actually, we're going to multiply by 60 to make it into a number of electrons per minute. So rearranging this, we get V times 60. So we're multiplying by 60 to go from electrons per second to electrons per minute, divided by 1.6 times 10 to the minus 19 times resistance is equal to electrons per minute, number of electrons per minute, as suggested in the question. And substituting in V is 4.5 and R is 1.6, we get that this is equal to, so number of electrons per minute is equal to so two significant figures. Tablet seems to have, so to two significant figures, substituting that into calculators is 1.05, so that rounds to 1.1 times 10 to the 21 electrons per minute.